Right now, as you settle in, there are roughly 300 million potentially habitable worlds scattered across our galaxy alone. 300 million places where liquid water could pool on cooling rock, where a sky could hold clouds, where something could, in principle, look up and wonder. The Milky Way is only one galaxy. It is a single island of light among an estimated 2 trillion others drifting through the observable universe. If even the smallest fraction of those worlds had ever stirred to life, the night above you should be crowded. It should be busy with signals, with engines, with the quiet industrial hum of a cosmos that woke up long ago. Our universe is 13.8 billion years old, a civilization that emerged just 1 billion years before us. A mere afternoon in cosmic time could have spread from star to star and settled the entire Milky Way in as little as 50 million years. That is a geological blink. They could have finished the whole galaxy before the first complex animals ever crawled across the floor of Earth's oceans. So the sky should already belong to someone. Every promising star should already be occupied. Every quiet corner should already carry a stranger's fingerprints. And yet, when we turn our most sensitive instruments toward the heavens and simply listen, we hear nothing. Not a whisper, not a word, only the faint static of an empty room. That contradiction has a name, though the man who gave it to us never intended one. On an ordinary afternoon in 1950, the physicist Enrico Fermi was walking to lunch with a few colleagues, talking about something else entirely. He stopped, almost mid-sentence, and asked a question that seemed to arrive from nowhere. Where is everybody? The men around the table did not need him to explain. They understood at once that he meant the others, the ones who should be out there, the civilizations the numbers all but promised. Nobody laughed at the premise. The premise was sound. Here is what most people get wrong about that silence. They assume it is empty because there is simply nothing out there to be heard. Yet the mathematics say otherwise. The mathematics say the sky should be loud. In 66 years of patient, systematic listening, across thousands of stars and countless frequencies, we have detected exactly one signal we cannot explain. It arrived once. It lasted 72 seconds. It is never returned. One knock, in more than half a century spent waiting at the door of the universe. That is the entire record. Into that silence, humanity has poured its oldest and most unsettling question. Not because the question is difficult to state, a child can ask where everyone is, but because every honest attempt to answer it leads somewhere strange or somewhere frightening, and very often both at the same time. There are, broadly, 3 explanations for why the cosmos seems so quiet. The first is that we are genuinely alone, the single flicker of thought in an ocean of dead worlds. The second is that we are not alone at all, but watched and deliberately left undisturbed. The third is the one that keeps certain scientists awake at night, that the silence is not an accident, but a strategy, that everyone out there is hiding and staying perfectly still for a very good reason. Not one of these 3 answers is comforting. Each of them, examined closely, changes what it means to be human on a small blue world circling an ordinary star. Over the next few hours, we are going to walk into each explanation slowly, carefully, and follow it as far down as it will go. If you find comfort in calm, deep journeys through the largest questions we know how to ask, take a quiet moment to hit the like button and to subscribe. It genuinely helps this channel grow, and it lets me keep making these long, unhurried explorations for you. There is no need to hold on tightly. You can let the words carry you wherever they drift. Settle in. Make yourself warm and comfortable. Let's begin. To understand a silence, you first have to meet the person who noticed it out loud. His name was Enrico Fermi, and the moment did not arrive in a lecture hall, or in front of an audience, or at the end of some long and formal debate. It arrived in the middle of an ordinary walk to lunch. It was the summer of 1950. Fermi was at the Los Alamos National Laboratory, in the high desert of New Mexico, in the company of 3 other physicists. Emil Konopinski, Edward Teller, and Herbert York. They were talking as colleagues talk, drifting easily from one subject to the next, when Fermi said something that had nothing obvious to do with anything around them. He asked, simply, "Where is everybody?" The remark came out of the blue. There had been no build-up, no warning, nothing in the conversation that would have prepared the others for it. And yet, according to Teller, who carried the memory of that afternoon for the rest of his life, the whole table dissolved into general laughter. Not because the question was absurd, not because it was unclear, but because every single person standing there understood, instantly and without a word of explanation, exactly what Fermi meant. He was not asking about lunch. He was not asking about a missing colleague. He was asking about the universe itself. He was asking why, in a cosmos this ancient and this vast, the sky above them was so completely, so stubbornly empty. That is the strange gravity of the question. It does not need to be spelled out. It arrives fully formed in the mind of anyone who has ever looked up on a dark, clear night and felt the sheer size of all that space pressing gently down on them. 4 brilliant men, waiting in a cafeteria line, heard a handful of words, and each of them reached the same enormous idea in the same instant. The laughter was not amusement, it was recognition. They were laughing the way people laugh when someone finally says out loud the thing everyone has quietly been carrying. Fermi was not the first to feel it. He was only the most famous. The unease he put into words that day had been circling through human thought for more than 300 years, long before rockets, long before radio, long before anyone even knew what a galaxy truly was. Careful minds had already begun to notice the quiet. In the year 1686, a French writer named Bernard Le Bovier de Fontenelle published a book called Conversations on the Plurality of Worlds. In its pages he imagined other planets crowded with inhabitants, worlds beyond counting, each turning with its own life. It was a beautiful thought. It was also quietly a troubling one, because if those worlds were truly out there and truly full, then their complete absence from our sky demanded some kind of answer. The wondering did not stop with him. Nearly 2 centuries later, in 1865, the novelist Jules Verne returned to the same puzzle in his story Around the Moon. And in 1933, the Russian rocket pioneer Konstantin Tsiolkovsky, one of the founding minds of all spaceflight, set the problem down in plain and sober terms. If the universe ought to be brimming with life, he reasoned, then something must account for the plain fact that none of it has ever come to visit us. The question, you see, was never really new. Fermi simply asked it, at last, in the presence of people who had the instruments to take it seriously. To feel why the question refuses to fade, you have to hold the numbers in your mind for a moment, slowly and without rushing. Our galaxy, the Milky Way, is not small. It contains somewhere between 200 billion and 400 billion stars. Not thousands, not millions, hundreds of billions of suns, each one a burning furnace, and a great many of them far older than our own. Every one of those points of light is a potential hearth. Every one is a place where the story could, in principle, begin again. And the galaxy is not merely crowded. It is vast in a way that defeats every instinct the human body was built with. From one edge to the other, the Milky Way stretches roughly 100,000 light-years across. That means light itself, the fastest thing that exists, moving quickly enough to circle our whole planet several times over in a single second, still needs 100,000 years simply to travel from one rim of our galaxy to the other. Think about that for a breath. A beam of light that set out from the far edge 100,000 years ago would only now be arriving here. The scale is not large, it is annihilating. Then there is time, which is where the deepest trouble begins. The universe is old. Not old in the way a person is old, or a mountain, or an empire. The universe has been expanding for approximately 13.8 billion years. Set against a number of that size, the whole of recorded human history, every kingdom, every language, every life that has ever been lived, occupies a sliver so impossibly thin that it very nearly vanishes. We are a single sentence written on the last page of an unimaginably long book. Here is what that depth of time quietly makes possible. Our Sun is a middle-aged star, unremarkable in almost every way. Countless other stars across the galaxy formed long before it, some of them billions of years earlier, in an era when the Earth did not yet exist. So if intelligent life is anything other than a miracle unique to this one world, then somewhere out there a civilization could have arisen not a little before us, but a full billion years before us. Consider, carefully, what a head start of 1 billion years would actually mean. It is not a matter of being slightly further along. It is a gap so wide that they, looking back at us, would see something closer to the first faint stirrings of life in a warm sea than to a fellow traveller. And this is the detail that turns simple curiosity into a genuine paradox. Crossing the galaxy is slow, yes, but it is not impossible, and it demands no physics we do not already understand. Even using ordinary travel, far below the speed of light, the kind of journey we could imagine building with nothing more than patience and time. Careful estimates suggest that a single determined civilization could spread itself across the entire Milky Way in somewhere between 5 million and 50 million years. That sounds like an eternity. Against the age of the galaxy, it is almost nothing at all. 5 million years, measured against 13.8 billion, is less than the blink of an eye measured against a human lifetime. Now follow that thought where it leads. If even one civilization had begun that patient expansion a billion years ago, it would have finished long before our earliest ancestors ever stood upright. The galaxy would already be settled. Every promising star would already be spoken for. The night sky would not be a mystery to us. It would be a map of someone else's country. There is in theory a way to make the crossing faster still. A civilization would not even need to make the whole journey itself. It could send out self-replicating machines, probes that arrive at a distant star, quietly mine the asteroids and rubble already drifting there, assemble faithful copies of themselves, and launch those copies onward toward the next star in turn. Each new world becomes a workshop for building the next wave. The expansion is not steady and linear, but doubling, and doubling again, and again after that. By some estimates, machines of this kind could reach and survey every last corner of the Milky Way in as little as 4 million years. One seed, patiently multiplying, could touch the whole garden. So the arithmetic leaves us standing in front of a wall. The galaxy is ancient. The galaxy is enormous. The galaxy is, by every reasonable estimate, crossable given time, and time is the one resource the universe possesses in overwhelming, almost obscene abundance. Every single ingredient for a sky crowded with neighbours is present and accounted for. The stars are there. The worlds are there. The head start is there. The clock has been running for billions of years, and still, when we turn our eyes and our instruments upward and actually look, we find nothing looking back. No ships crossing between the stars, no cities burning on distant worlds, no message, no beacon, no whisper. Only the slow, indifferent turning of the constellations and the deep, patient quiet that has never once been broken. That contradiction is not a small gap in our understanding, the kind that a little more data might comfortably fill. It is a hole at the very center of everything we think we know about our place in existence. The equations promise company. The sky delivers solitude, and for a very long time, the only thing anyone could do when faced with that gulf was to sit in a room and argue about it, trading intuitions across a table, none of them able to prove a thing. The problem with an argument like that is that it never ends. It only circles. It only deepens, until, at last, one man decided he had heard enough of the arguing, and chose instead to do something almost no one had ever seriously tried before. He decided to stop guessing whether anyone was out there, and to point a great metal ear at the heavens, and simply listen. The man was Frank Drake, and the idea that made his listening possible had arrived only a year before, from two physicists who never once touched the machine that would test it. In 1959, Giuseppe Cocconi and Philip Morrison, working together at Cornell University in Ithaca, New York, published a short paper in the journal Nature. Its title was plain and almost absurdly modest for what it proposed: searching for interstellar communications. They were not claiming that aliens existed. They were asking a smaller and far more useful question. If someone out there wanted to be heard across the emptiness, on which channel would they choose to call? This is the quiet genius of the paper. The problem with searching the sky for a signal is not that the sky is silent. The problem is that the sky is enormous, and the range of possible frequencies is nearly infinite. Cocconi and Morrison understood that you could not simply listen everywhere at once. You needed a shared assumption. You needed a frequency that any thinking creature, anywhere, would recognize as special, not because it was beautiful, not because it was convenient, but because it was written into the structure of the universe itself. They found it in hydrogen. Hydrogen is the most abundant element in the cosmos, the raw material of every star, and it emits radio energy at a single precise frequency, near 1420 MHz. Any civilization advanced enough to build a radio telescope would inevitably discover this frequency, because they would use it to map their own galaxy. It was, the two physicists argued, a kind of natural meeting place, a cosmic watering hole where the thirsty of every species might gather without ever having agreed to meet. If you wanted to be found, you would broadcast there, and if you wanted to find someone, that is exactly where you would point your ear. Frank Drake had been thinking along the same lines, entirely on his own, and unlike the theorists, he had access to a telescope. In the spring of 1960, at the National Radio Astronomy Observatory in Green Bank, West Virginia, tucked into a quiet valley in the Allegheny Mountains chosen specifically for its silence, Drake prepared to do something that had never been done as a serious scientific experiment. He would aim a great dish at the stars and listen for a message from another world. Consider what this required of a young astronomer in 1960. The subject of alien life was not respectable. It belonged to pulp magazines and late-night radio, not to careful men with reputations to protect. Drake kept his preparations quiet, almost embarrassed, because he understood that if the search found nothing, the failure would attach itself to his name. He named the project Ozma, after the princess of a faraway and imaginary land in the Oz stories, a place said to be populated by strange and exotic beings. It was a private joke, and also a confession. He was reaching for a fairy tale, and he knew it, and he did it anyway. On the 8th of April, 1960, before dawn, Drake began. The instrument was an 85-foot radio telescope, a curved metal ear roughly the width of a modern city intersection, tuned to that magic hydrogen frequency Cocconi and Morrison had marked out. He chose his targets with care, not the whole sky, which was hopeless, only two stars, Tau Ceti and Epsilon Eridani, both of them sun-like, both of them close by the merciless standards of interstellar distance, each lying roughly 11 light-years from Earth. Close enough that a signal could cross the gap in a human lifetime. Close enough to hope. 11 light-years is worth pausing on, because the word close is doing an enormous amount of work. If you could somehow board the fastest spacecraft humanity has ever launched and aim it at Tau Ceti, the journey would not take years. It would take tens of thousands of years, longer than all of recorded human history stretched end to end, and multiplied many times over. These were the nearest reasonable candidates. These were the neighbours, and the neighbours were so far away that light itself, the fastest thing in existence, needed more than a decade simply to arrive. Drake was not listening across a room. He was listening across an abyss so wide that the sound of his own civilization, had he made one, would take 11 years to reach the doorstep he was watching. He listened for weeks. Between April and July of 1960, Drake and his small team gathered roughly 150 hours of observation, sweeping that narrow band of frequency, waiting for a pattern to rise out of the wash of cosmic static. The work was tedious in the way that all genuine discovery is tedious. Hour after hour of noise, the hiss of the universe, which sounds like nothing so much as the faint crackle between stations on an old radio. And then, one day, without warning, the machine screamed. A signal came through, strong and rhythmic and utterly unlike the background hiss. For a few electric moments, the small team at Green Bank stood at the edge of the most important discovery in human history. The pattern was there. Something was broadcasting. And then, as quickly as it had come, doubt arrived with it. The signal was too strong, too clean, too easy. When they checked it against the sky and against the calendar, the answer resolved into something disappointingly terrestrial. It was not a message from Tau Ceti. It was almost certainly a passing aircraft, and the best guess of those involved was that it had been a secret military plane, likely one of the high-altitude U-2 reconnaissance craft, then flying missions the public knew nothing about. The first candidate signal in the history of the search for alien life was not an alien at all. It was our own species, spying on itself, 13 miles up, and that is the shape the search would take for the next 66 years. A flicker of hope, examined closely, dissolving back into the ordinary. Project Ozma ended in the summer of 1960 with no message, no beacon, no whisper from Tau Ceti or Epsilon Eridani. Two sun-like stars, patiently watched, and both of them silent. Drake had built the ear. He had aimed it at the most promising doorways in the neighborhood. He had knocked, and no one had answered. This is where the true weight of the problem finally settles into place. It is one thing to argue at a lunch table that the universe should be crowded. It is another thing entirely to point a real instrument at a real star and hear nothing come back. Drake's silence was not the comfortable silence of a question no one had bothered to ask. It was the harder, colder silence of a question asked directly, out loud, into the dark, and met with no reply. The theorists could keep their equations. The sky had begun, for the first time, to answer with data. And the data said nothing. Everything that came after Project Ozma would be a variation on that first quiet night. Larger telescopes, wider surveys, millions of stars instead of two. Frequencies stacked upon frequencies, decades of listening, the most sensitive instruments the human species has ever constructed, all of them straining toward the same faint hope. And through all of it, from that spring morning in West Virginia to the present day, the fundamental result has never changed. We look, and we do not find. We call, and no one calls back. The numbers insisted the galaxy should be teeming with voices. The instruments, when finally switched on, recorded only the hiss of hydrogen and the accidental echo of our own machines. The probability said they should be here. Reality said they were not. Something in our assumptions had to be wrong. The man who had switched on that first machine understood the silence better than anyone alive. Frank Drake had spent 150 hours pointing a dish at two quiet stars and hearing nothing. And he had come away from that experience not discouraged, but strangely clarified. He had learnt something that no amount of theorizing could have taught him. The problem was not that we lacked the will to listen. The problem was that we did not know what we were listening for, or how many voices we had any right to expect. The galaxy might hold 1 million civilizations, or it might hold exactly one, and nothing in our science, as of that moment, could tell the difference between those two universes. So Drake decided to do the only reasonable thing a scientist can do when confronted with a question too large to answer. He broke it into smaller questions. In the autumn of the following year, on the 1st of November, 1961, Frank Drake gathered a small group of researchers at the National Radio Astronomy Observatory in Green Bank, West Virginia, the same Green Valley from which he had run Project Ozma. It was the first scientific conference ever convened on the subject of extraterrestrial intelligence. 10 people attended. Among them sat a young astronomer named Carl Sagan, still years away from becoming the most famous scientific voice of his generation. There was Philip Morrison, who had helped propose radio contact in the first place. There was the neuroscientist John Lilly, who studied the minds of dolphins, and the observatory's own director, Otto Struve. And there was the chemist Melvin Calvin, who during the course of that very meeting received a telephone call informing him that he had just been awarded the Nobel Prize in Chemistry. It was, by any measure, a remarkable room. But the most important object in that room was not any of the people. It was a single line of symbols that Drake had written on the blackboard to give the meeting an agenda. He had not intended it to become famous. He had needed a way to organize the discussion, a checklist of every factor that would have to be known before anyone could seriously estimate how many communicating civilizations existed in the Milky Way at this moment. So he wrote them down in sequence, each one a fraction or a quantity that fed into the next. How many stars are born in our galaxy each year? What fraction of those stars have planets? How many of those planets, on average, could support life? On what fraction of those suitable worlds does life actually begin? Where life begins, how often does it become intelligent? Where intelligence arises, how often does it build a technology capable of sending signals across space? And finally, the term that would come to haunt everyone who studied it. How long does such a civilization survive and keep broadcasting before it falls silent? Multiply all of these together, and out the other end comes a single number. The number of voices that should, right now, be calling out across the dark. This is the deceptive genius of what became known as the Drake equation. It looks like a formula for calculating an answer. It is not. It is a formula for organizing our ignorance. Each term in that line of symbols represents a genuine physical quantity, something that either has a true value or does not, whether or not we happen to know it. The equation does not manufacture knowledge. It takes the single unanswerable question, are we alone? And it factors that question into 7 smaller questions, each of which can in principle be attacked by a different branch of science. Astronomy can measure the birth rate of stars. Planetary science can count the worlds. Biology can, someday, speak to the odds of life igniting. The value of the equation was never the product at the end. The value was the diagnosis. It told us precisely where our ignorance lived. And when Drake and his colleagues plugged in their best guesses that week, the answer they arrived at was almost comically wide. Depending on how optimistic or how cautious one chose to be about each term, the number of communicating civilizations in the Milky Way came out somewhere between 1,000 and 100 million. Consider what that range actually means. It is not a measurement, it is a confession. It says that our uncertainty about our own cosmic company spans 5 orders of magnitude, a factor of 100,000. From a galaxy sparsely dotted with a handful of lonely broadcasters, to a galaxy so crowded with intelligence that signals should be pouring past the Earth in every direction at every hour. Both answers came from the same equation. Both were defensible. The difference lay entirely in what you were willing to assume about the terms nobody could yet measure. For decades, the leftmost terms of that equation were the softest, the most open to argument. Nobody knew what fraction of stars carried planets. It was possible, in 1961, for a serious astronomer to wonder aloud whether planets were common, or whether our solar system was some rare accident of stellar chemistry. That uncertainty is now gone. It was erased by a single spacecraft. Beginning in 2009, NASA's Kepler Space Telescope stared without blinking at a single patch of sky, watching more than 150,000 stars for the faint, regular dimming that betrays a planet crossing in front of its sun. Over 9 years it confirmed more than 2,800 new worlds, and from that harvest emerged a conclusion that would have astonished the 10 people in that room at Green Bank. Planets are not rare. Planets are the rule. Roughly half of all stars similar to our Sun appear to host a rocky planet orbiting within the habitable zone, the narrow band of distance where a world is neither so close that its oceans boil away, nor so far that they freeze into permanent stone. Run that fraction across the whole of the Milky Way, and the numbers become almost unbearable to hold in the mind. The best estimates drawn from Kepler's data suggest that our galaxy contains something on the order of 300 million potentially habitable rocky worlds. 300 million places where liquid water could, in principle, pool on a solid surface beneath an open sky. And these are not all safely tucked away in the unreachable distance. At least 4 of those candidate worlds are thought to lie within 30 light-years of the Earth, and the nearest may sit closer than 20. To feel the strangeness of that, picture the sky as a city and the stars as its houses. In our immediate neighbourhood, within a walk of a few doors, several of the homes appear to have gardens capable of growing life. 2 of the terms that Drake could only guess at, the fraction of stars with planets and the number of habitable worlds per system, have been dragged out of speculation and into the light of real measurement, and every measurement has pushed them upward, toward more worlds, toward more chances, toward a galaxy that should, by every early expectation, be teeming, which is exactly why the silence has grown, over the years, not quieter but louder. When Drake wrote his equation, one could still imagine that the great emptiness of our radio surveys reflected a simple scarcity of planets. Perhaps there was simply nowhere for life to stand. That comfortable explanation is now closed to us. The places exist. We have counted them. The gardens are there, in their hundreds of millions, and still no one answers the door. This is the disquieting reality of the Drake equation in the 21st century. The terms we have learnt to measure keep making the case for company. The terms we cannot yet measure must therefore be carrying an enormous and terrible weight, holding the final number down against all that abundance, and we do not know which of them it is. Because here is the property of that equation that its elegant appearance hides. If even one of its terms is a very small fraction, a number close to 0, then it does not matter how generous every other term turns out to be. Multiplication is merciless in this way. You may have 400 billion stars, you may have 300 million habitable worlds, you may have oceans and stable suns and all the raw time in the world, but multiply that grand inheritance by a single fraction with enough zeros in front of it, and the product collapses toward nothing. The whole galaxy of possibility can be extinguished by one unlucky step somewhere in the chain from dead chemistry to a creature that builds a radio. And so the question the equation quietly poses is not whether we are alone. It is sharper and stranger than that. Which term is the killer? Somewhere in that line of symbols on a 1961 blackboard hides the answer to why the sky is silent, and we cannot yet read which symbol it is. The modern attempts to fill in the equation with everything we have learned in the 60-odd years since only deepen the vertigo. Depending on the assumptions a given researcher makes about the biological terms, the terms concerning how readily life begins and how often it climbs toward intelligence, the recalculated number of civilizations in the Milky Way now ranges from as high as 15.5 million down to a figure so small it is difficult to write in words. Roughly 9 chances in 10 trillion. That lower estimate does not describe a rare galaxy. It describes an empty one. It says that the expected number of technological civilizations in the entire Milky Way, ourselves included, rounds down to less than 1. 2 honest calculations, built from the same equation and the same universe, and one of them fills the galaxy with millions of neighbors, while the other leaves us utterly and permanently alone. The equation has not narrowed our ignorance. It has only shown us, with terrible precision, the exact shape of the thing we do not know. Consider what the equation actually is. It is not a formula in the sense that most equations are, a machine that takes known quantities and returns a settled answer. It is a chain of 7 numbers multiplied one after another, each one a fraction, each one a gate that the running total must pass through before the next gate can act on it. The first number is the rate at which suitable stars are born in our galaxy. The second is the fraction of those stars that carry planets. The third is the number of worlds in each of those systems where life could take hold. And so the chain descends, each link narrower than the one above it, until it reaches the final number at the bottom, the length of time a civilization spends broadcasting into the dark before it falls silent. Here is the quiet revolution that has happened in the 6 decades since Frank Drake first chalked those terms onto a blackboard. The top of the chain has been measured. When Drake wrote the equation in 1961, every single term was a guess, and some of them were guesses about things no human being had ever observed. Nobody knew whether other stars had planets at all. It was possible, in that room, to believe that our own solar system was a freak accident, the only gathering of worlds in the entire galaxy. Then came the long, patient labor of the planet hunters, and above all a spacecraft named Kepler. Kepler was a telescope, and it stared. From 2009 to 2018, it watched a single patch of sky holding more than 100,000 stars, waiting for the almost imperceptible dimming that occurs when a planet crosses the face of its sun. That dimming is faint beyond ordinary imagination. It is the difference a moth makes crossing a searchlight, seen from another continent. Kepler caught it anyway, again and again, more than 2,800 worlds confirmed, until a truth emerged that would have stunned the 10 people at that first meeting. Roughly half of all sun-like stars host a rocky planet in the habitable zone, the narrow band where water can pool as a liquid. Not a handful of stars, not 1 in 1,000. Half. Run that fraction across the whole galaxy, and the figure that falls out is staggering. Something on the order of 300 million potentially habitable rocky worlds in the Milky Way alone. 300 million places where the temperature is right and the chemistry is possible. These are not distant abstractions scattered only across the far rim of the galaxy. At least 4 such candidate worlds are thought to lie within 30 light-years of where you are sitting. The nearest may be closer than 20. In cosmic terms, that is not across town. That is a house on the same short street. If you could stand on the surface of the nearest of those worlds and turn to find our sun in its sky, our sun would be nothing special. One faint point among thousands, giving no hint that a species here had spent decades listening for a whisper. That is the strange symmetry of the whole problem. Every one of those 300 million worlds is, to every other, merely a distant light. Any of them could hold a civilization staring back at an equally silent sky, asking the very same question, and neither of us would ever know. So the first terms of Drake's chain, the ones that once demanded pure faith, have been handed over to observation. We no longer guess how many worlds there are. We count them. This is what makes the modern silence so much heavier than the silence of 1961. The people in that room could comfort themselves that the emptiness was only a measure of their ignorance, that perhaps planets were simply rare. That comfort is gone. The planets are there in their hundreds of millions, and still nothing calls. The vertigo lives in the lower half of the chain, because while the astronomers were counting worlds, the biologists were left holding the terms no telescope can reach. What fraction of habitable worlds actually give rise to life? What fraction of living worlds ever produce intelligence? What fraction of intelligent species build something that broadcasts? Not one of these numbers has ever been measured, because we possess exactly one example of a living world, and drawing a statistical law from a single case is not science. It is a guess wearing the costume of a number. This is why 2 careful researchers can take the identical equation and arrive at answers separated by nearly 20 powers of 10. The disagreement is not about the sky. The disagreement is about ourselves. Think about what that spread truly contains. On one end sits a galaxy warm with company, more than 15 million voices, a night sky that ought to hum with signals. On the other end sits a galaxy in which the expected number of civilizations, ourselves counted, does not reach a single whole one. Both figures were produced by serious people applying honest reasoning to the same set of facts. The gulf between them is not a gap in the data about the stars. It is the exact measure of how little we understand the road from lifeless chemistry to a creature that can look up and wonder about the stars at all. Here is the genuine gift the equation gives us, the reason it endures long after its author has gone. Its worth was never the answer at the bottom. Its worth is that it isolates the unknown. It takes the vast, unanswerable question, are we alone, and breaks it into a row of smaller questions, and it shows that the entire mystery of the cosmic silence must be hiding inside one or two of those terms. Somewhere along that chain there is a number that is nearly zero. There has to be. The stars are real, the planets are real, the time available is real, and yet the galaxy is quiet. So one of the links, one of the gates, must be almost closed. The equation cannot tell us which one. It tells us instead, with the flat certainty of arithmetic, that such a gate exists. Consider what this means for you, standing at a window on an ordinary night. Every point of light you can see is a sun, and around a great many of them, we now know, there are worlds where rain could fall. The sky is not empty of places, it is crowded with them. And the reason you have never once in your whole life seen a single sign that anyone lives out there is not that the houses are missing. The houses are built. The lights, for reasons we do not understand, are simply never on. You are looking at a city at midnight where every window is dark, and you cannot tell whether the city stands abandoned, or whether everyone inside has learned to keep very, very still. That dark gate somewhere in the chain has a name, given to it decades after Drake by a thinker who followed the logic to its coldest conclusion. He called it the filter. The terrible thing about a filter is that it does not care where along the chain it sits. It could lie far behind us, in the improbable spark that first taught a molecule to copy itself, in which case we are the rare survivors of a trial almost nothing passes. Or it could lie ahead of us, waiting, in some step no civilization has ever cleared. The equation gives us the shape of the wall. It does not tell us whether we have already climbed it, or whether we are still walking toward it, in the dark, unaware. The thinker who gave that wall its name was not an astronomer. He was an economist. His name was Robin Hanson, and on the 15th of September, 1998, he set down a short piece of reasoning that almost no one in mainstream science wanted to sit with for very long. He called the idea the Great Filter. It was not an equation. It was not a survey of the sky. It was a single patient thought, followed all the way down to the place where thoughts turn cold. The thought begins with something we never think to question. We exist. Between the lifeless chemistry of the early universe and a creature capable of building a radio telescope and aiming it at the stars, there stretches an enormous staircase of transitions. Each stair is a thing that had to happen. Each stair is a thing that very nearly might not have. Hansen counted roughly 9 of these steps between dead matter and a civilization able to reach across a galaxy. And every single one of them is a place where the story could have quietly stopped. Consider the staircase from the bottom. The first step is not the appearance of a fish, or a forest, or a mind. It is smaller than that, and stranger. It is the moment a molecule first learned to copy itself. Not because some hand assembled it, but because in the churning chemistry of a young world, one arrangement of atoms happened upon the trick of making crude copies of its own shape. This is the beginning of everything that would ever live. We do not know how likely it was. We do not know whether it happens on a billion worlds, or whether it happened here once and nowhere else in the reachable universe. The next step waits above it, a simple cell, a single bag of chemistry holding itself apart from the water around it, feeding, dividing, enduring. For most of Earth's history, this was the entire cast of characters, nothing but the smallest possible life, patient and mindless, filling the oceans for billions of years without ever becoming anything more. Then, higher on the staircase, the complex cell. A cell with an inner architecture, with a sealed core, with machinery folded inside machinery. On our world, this transition seems to have happened only once, and it took an almost unimaginable span of time to arrive. Above that, more steps, each one a wager the universe did not have to win. The braiding together of 2 lineages, the invention of inheritance shared rather than merely copied. The gathering of single cells into a single body, many small lives agreeing to become one large one. The slow arrival of animals clever enough to handle tools, to carry a thought from one moment into the next. And then, near the very top, the thing we are. A tool-using animal with a brain, vast enough to model the sky, to write down numbers, to ask aloud where everyone else has gone. Roughly 9 steps then, from a self-copying speck to a species that builds machines to listen to the dark. Here is the part that should hold you still. Every step on that staircase took time, and most of them took incomprehensible amounts of it. The staircase is long not because the universe is slow, but because each step is improbable, a lock that only rarely finds its key. And this is where Hansen's quiet thought turns into something that presses against the chest. Somewhere on that staircase sits a step so difficult that almost nothing ever climbs it. That is the filter. That is the wall. We know it must be there, because if every step were easy, the galaxy would be crowded, loud, unmistakable. And it is none of those things. It is empty and it is silent. So at least one of those steps must be a near impossible thing. Imagine you could rerun the history of this planet 1,000 times over, wind it back to the molten beginning, and let it play forward again, and again, and again. On how many of those 1,000 Earths does a self-copying molecule ever appear? On how many of the ones that clear that first hurdle does the complex cell ever form? On how many of those does anything ever grow large enough to wonder about the stars? Hansen's argument is that the honest answer, for at least one of those steps, is almost none. That the great majority of those 1,000 Earths would remain forever silent, forever simple, forever asleep. And we have no way, from inside our single run of the experiment, to know which step is the one that stops them. The question that follows is the coldest question in this entire subject. Where on the staircase does the filter sit? Not somewhere vague, somewhere exact. Either it lies below us, on a step we have already climbed, or it lies above us, on a step we have not yet reached. Those are the only 2 possibilities, and they could not differ more in what they mean for us. Consider the first. Suppose the filter is behind us. Suppose the near impossible step was the very first spark, the molecule that learned to copy itself, or the complex cell that took billions of years to appear. If that is true, then the reason the galaxy is silent is simply that life almost never begins at all, or almost never grows complex enough to matter. We are not surrounded by neighbours, because there are almost no neighbours to have. We would be, in the most literal sense, a miracle, rare survivors of a trial that nearly everything fails. And that, strange as it sounds, would be the good news. Because if the hardest step is already beneath our feet, then the road ahead of us might be open. The stars might simply be waiting. Now consider the second possibility, and consider it slowly. Suppose the filter is not behind us. Suppose the early steps are common, that life ignites easily, that complex cells and animals, and even intelligence arise on countless worlds. If all of that is true, and the galaxy is still silent, then the near impossible step is not in our past. It is in our future. It is a wall that every civilization walks toward, and reaches, and does not pass. Some barrier waits on a stair just above the one we now stand on, and no one who has ever climbed this far has ever made it through. Not because they were foolish, not because they were unlucky, but because the barrier is simply there, for everyone, without exception, and we have not yet arrived at it. This is why a short paper by an economist unsettles people who have looked at it clearly. It takes the emptiness of the sky and turns it into a question about our own survival. If they are not out there, one of 2 things must be true. We are astonishingly rare, or we are astonishingly doomed. The silence itself will not tell us which. It only tells us that one of them is so. And then Hansen noticed something small, a coincidence buried in the numbers, that makes the darker reading harder to wave away. Think about how long it took life on Earth to produce us. Billions of years, step after step after step, each transition swallowing vast stretches of time. Now ask how much time this planet has left as a living world. The sun grows slowly brighter as it ages, and in something like 300 million years, the conditions that permit complex life here begin to close. 300 million years sounds enormous. Against a single human life, it is beyond imagining. But set it beside the length of a single step on that staircase, and something troubling appears. Each hard step, on average, seems to take roughly as long as that entire remaining window. We did not arrive with billions of years to spare. We arrived close to the deadline, almost late. Consider what that means. If intelligence were easy, if the steps were quick, we should have appeared early in Earth's habitable lifetime, with immense time to spare, the way a simple task is finished long before the clock runs out. Instead, we appear near the very end of the allotted time, like a runner crossing the line as the light is already fading. And a task that is only just finished before the deadline is almost always a task that was very nearly not finished at all. The timing whispers that the steps behind us were brutally hard, that we are not the ordinary product of a fertile universe, but the last survivor of a gauntlet almost nothing clears. If that reading is correct, it is oddly a comfort. It places the filter firmly in our past. It would mean the silence is not a warning but a measurement, a record of how alone and how improbable we truly are. And yet the same reasoning carries a second edge, and the other edge is where the dread lives. Because nearly everything we are learning about the wider universe seems to be making the early steps look easier, not harder. Every world we find with water, every organic molecule discovered drifting in a cloud between the stars, every hint that the ingredients of life are ordinary and everywhere, does something quietly frightening. It lifts weight off the steps behind us and sets it down on the steps ahead. Each discovery that says beginnings are common is also, without meaning to, a discovery that says the wall is more likely still in front of us. And so we arrive at one of the most unsettling ideas ever produced by careful thought. There is a place we could look, a simple thing we could find, that would be, by any ordinary measure, the greatest discovery in the history of our species, and it might also be the worst news we have ever received. The place is Mars. The simple thing is a single living cell. Picture a robotic drill, some decades from now, biting into the cold rust of a Martian plain and lifting a core of ancient sediment into the light. Picture a technician in a sealed laboratory, leaning close and seeing pressed into that rock the unmistakable outline of something that once lived. By any ordinary measure, this would be the most important discovery our species has ever made. It would mean we are not alone. It would mean that life is not a single freakish accident that happened here and nowhere else. And that is exactly why the careful thinkers who study this question would receive the news with something close to grief. To understand the fear, you have to follow the reasoning the way Robin Hanson followed it. Mars and Earth are two separate worlds, divided by a vast and sterilizing gulf of vacuum. If life arose on each of them on its own, then life did not begin once in this solar system, it began twice. And if the spark of living chemistry can catch twice in a single ordinary star system, then it very likely catches on countless worlds across the galaxy. If life is that easy to start, then the very first and hardest of the early steps, the leap from lifeless matter to a molecule that copies itself, was never the wall at all. It was a doorway that almost everything walks through. And here is the turn that makes the discovery so bleak. The galaxy is still empty. The silence is still real. Something still stops the overwhelming majority of beginnings from ever becoming a civilization that spreads among the stars. So if the early steps turn out to be easy, the barrier does not vanish. It simply moves, not behind us, into the deep past where it could never touch us again, but ahead of us, into the short stretch of road we have not yet walked. Consider what that would mean for a species like ours. We have already crossed nearly every early step. We are colonies of cells that learn to act as one. We are animals with large brains and hands that reshape the world. We have built machines that listen to the sky and machines that speak into it. If the wall is not behind us in the biology, then it stands somewhere in the narrow distance between where we are now and a true settlement of the stars. What could such a wall be? The honest answer is that nobody knows. It might be that the gulfs between stars are simply too wide, a moat no living thing ever truly crosses, so that every civilization exhausts its one world and falls quiet. It might be that the same intelligence which builds a radio telescope also builds the means of its own undoing, and that the window between the two is always, everywhere, fatally brief. Whatever it is, it would have to be nearly total. Not a hazard that claims a few of the unlucky, but a barrier that stops almost everyone. A filter that caught only half of all civilizations would still leave the galaxy crowded with the surviving half, and the sky over us would not be silent. So this is why a fossil on Mars would be, in the strangest sense, terrible news. Not because the microbe itself could ever harm us. It would be long dead, smaller than a grain of dust, utterly powerless. But because of what its mere existence would whisper about the shape of the road in front of us. A lifeless Mars lets us keep our hope. It allows us to believe that the improbable step, the one that almost never happens, is already behind us, and that our loneliness is simply the loneliness of the genuinely rare. A Mars with life takes that comfort away. The more common life turns out to be, the more certain it becomes that whatever ends civilizations has not yet arrived for us. Sit with that for a moment, in the dark, at the pace of a slow and steady heartbeat. Everything you have ever known, every language, every song, every act of tenderness and cruelty in the whole of human history may be one small civilization's brief walk across a room, moving toward a door that no one has ever been seen to walk back out of. This is not despair. It is not even a prediction. It is only a possibility, held up honestly to the light. But it is a possibility that quietly reframes every probe we launch and every signal we send. We are not merely exploring, we are testing, with our own survival as the instrument, exactly where the wall is standing. There is a second, quieter piece of evidence that points in the same unsettling direction, and it hides inside the calendar of the Earth itself. Our planet has been habitable for billions of years, and it has perhaps another 300 million years of habitability remaining before the slow brightening of the sun scorches its surface beyond the reach of life. 300 million years sounds like an ocean of time, but it is roughly the same length of time that each of the hard evolutionary steps appears to have needed. And that is a strange and revealing coincidence. If intelligence were easy, if it emerged quickly and reliably wherever the conditions allowed, we would expect to have appeared early in our planet's long habitable window, with billions of unhurried years still ahead of us. Instead, we arrived near the closing bell, with only about one hard step's worth of time to spare. Hansen understood what that timing implies. When a difficult process only just manages to finish before its deadline, it usually means the process was improbably hard, a long shot that barely succeeded in the time it was given. Intelligent life on Earth may be exactly that kind of long shot. Not the natural harvest of a warm planet and enough patience, but a near miss. A chain of unlikely accidents that very nearly did not happen at all. If that reading is the true one, then the filter really does lie behind us, and the emptiness overhead is the emptiness of a rare and fragile thing gazing out at a universe that produced almost nothing else quite like it. And so the very same evidence pulls in two opposite directions at once, and the direction it finally pulls decides whether our future is luminous or nearly hopeless. If life is rare, then we are precious, and the road ahead may be wide open. If life is ordinary, then we are ordinary too, and something we cannot yet see is waiting on that road for everyone who travels it. The entire weight of the question comes to rest on a single measurement we have not yet made: whether anything, anywhere, ever lived beyond the Earth. We are, in a real sense, still holding our breath. But there is another way to read the great silence altogether, a way that does not ask whether life is rare or common at all, But whether the ordinary conditions we take for granted, the moon in our sky, the giant planets guarding our flank, the slow machinery grinding beneath our feet, are stranger and more improbable than we have ever quite dared to believe. In the year 2000, two scientists set out to make that discomfort precise. A geologist named Peter Ward and an astronomer named Donald Brownlee gathered the scattered findings of their two fields and pressed them into a single book. They gave it a title that reads almost like a confession: Rare Earth. The argument inside was quiet and patient, and it is very difficult to shake once you have truly heard it. Simple life, they proposed, might be common across the cosmos. Microbes might stain 1 billion distant shores, but complex life, the kind that grows and moves and eventually lifts its eyes to the sky, might be among the rarest things the universe ever manages to make. To feel the full force of that claim, we have to return to a single word that has been quietly carrying an enormous weight: habitable. When you hear that 300 million worlds in our galaxy may be habitable, the word arrives wrapped in promise. It sounds like 300 million places where something could be alive at this very moment. 300 million skies with something breathing beneath them. That impression feels natural and obvious. And it is almost entirely misleading. That comfortable impression is wrong, not slightly wrong. Wrong in a way that reshapes the entire question. Because when astronomers call a world habitable, they are not describing a garden. They are describing one measurement, and one measurement alone: distance. A habitable world, in the careful language of the surveys, is simply a rocky planet orbiting in the narrow band around its star, where the surface temperature would allow liquid water to exist. That is the whole of it. Not oceans, not breathable air, not soil, not seasons, not shelter. Only the bare possibility that water, if any water were present, might neither freeze into stone nor boil away into nothing. The reason the word deceives us is that our minds cannot leave it empty. Students learn the phrase and immediately picture the Earth. Documentaries repeat it over soft and hopeful music. The imagination floods the hollow word with everything it already loves about its own home: the blue of the sea, the green of the hills, the warmth of an afternoon, and it hands all of that tenderness to a faraway speck of temperature about which we know almost nothing else. Habitable does not promise a living world. It promises only that one obstacle, a single link in a long and unforgiving chain, has happened to hold. And that was the heart of what Ward and Brownlee were saying. Habitability is not a property a planet simply has. It is a chain of coincidences, and every link must hold at once. Break any one of them, and the world may stay warm and wet and utterly, permanently barren. So consider the links, one at a time, the way they did, and watch how quickly 300 million begins to shrink. Consider the star first. Our sun is a steady, patient, middle-aged yellow star, the kind astronomers mark with the letter G. It has shone at nearly the same brightness for billions of years, and it will go on shining for billions more. That steadiness is not the ordinary way of things. It is a rare kind of mercy. Complex life does not appear in an afternoon. It requires vast, uninterrupted stretches of calm, hundreds of millions of years in which nothing catastrophic arrives to reset the experiment. A star that flickers, that swells or convulses across those spans, offers no such patience. Life there would not be poisoned so much as never given the time to begin. But the right kind of star is only the beginning. The planet must also sit in the right place within the galaxy itself. Not everywhere in the Milky Way is equally kind to living things. There is thought to be a preferred band, a galactic habitable zone, set well away from the crowded and violent heart of the galaxy, and drawn back from the barren and lonely edge. Too far inward, and the sky becomes a dangerous neighborhood. Too far outward, and the raw materials that living worlds are built from grow thin. Our solar system rides quietly in that comfortable middle lane, and we did not choose it. We simply happened to be born there. Then comes the moon, and here the improbability turns genuinely strange. The moon that hangs in our sky is not a small companion. It is enormous, absurdly large for a world of Earth's size, and its presence is not decorative. It is stabilizing. A planet spinning alone tends to wobble on its axis over long ages, and that wandering tilt can throw a climate into violent extremes, tipping a world through savage swings of heat and cold that no complex creature could ever follow. Our great moon holds the Earth steady. It pins our tilt gently in place, and it has done so across the entire long, unbroken story of animal life, not as a gift we earned, but as an accident we inherited. Without it, the seasons themselves might have been too chaotic to survive. Beyond the moon stand the giants. Far out in the cold, the great gas planets, Jupiter chief among them, wheel slowly through the dark. For most of human history they seemed magnificent and irrelevant, beautiful lights with no bearing on our lives. That impression was wrong. Their immense gravity acts as a shield. Across the eons, countless comets and asteroids fall inward toward the sun, and many of them are caught, flung aside, or swallowed whole by those distant giants, before they can ever reach us. Not all of them, of course. Enough have struck the Earth to leave scars and to end whole chapters of life. But the bombardment we do endure is only a fraction of what an unguarded world would suffer. The giants keep watch on our flank, and they ask nothing in return. And then, beneath our very feet, there is the slow machinery. The ground you are resting on right now is not truly fixed. It moves. The continents drift across the planet at the pace a fingernail grows, riding a churning layer of rock, and this restless motion is not a flaw in our world. It may be one of the deepest reasons it lives. This slow grinding of plate against plate does something no still world can manage. It cycles carbon through the crust, drawing it down and returning it over enormous spans of time, and in doing so it acts as a thermostat, a planetary regulator that has kept the climate within the narrow bounds life can bear across billions of years. A world without this machinery might warm without limit, or freeze without relief. Ours corrects itself, quietly, endlessly, and entirely without our knowledge. So look again at what the word habitable actually asks for. Not merely the right distance from a star, but the right kind of star, and the right neighborhood within the galaxy, and a moon improbably large enough to steady the sky, and distant giants patient enough to guard the approaches, and a living, moving crust beneath everything, turning over on itself to keep the temperature kind. Each of these is a coincidence, and habitability, in the full and honest sense, is not the presence of any one of them. It is the presence of all of them together, at the same time, on the same fragile world. This is the unsettling gift of the rare Earth idea. It does not require that life be forbidden. It needs no great wall, no cosmic disaster, no dark logic of any kind. It needs only multiplication. Take a very large number and multiply it by a small fraction, and then by another small fraction, and another, and another. And watch how quickly the largest number in the world can dwindle toward a single one. 300 million worlds where water might not freeze, but only a sliver of those with the right star, and a sliver of that sliver in the right place in the galaxy, and a sliver of that with a stabilizing moon, and a sliver of that with its own guardian giants, and a sliver of that with a crust that moves. The winnowing is merciless, and it is carried out not by any enemy, but by arithmetic alone. And so the word that once sounded so full of promise reveals its second face. 300 million habitable worlds may be perfectly real, and nearly all of them may be sterile stone and sterile sea, warm and wet and empty, worlds where the temperature is exactly right and nothing has ever stirred, and nothing ever will. The silence, read this way, is not the silence of the dead, and not the silence of the hidden. It is the silence of the truly staggeringly rare. Perhaps no one is answering because there is almost no one out there at all. Sit with that possibility for a moment, because it carries a strange and double weight. If Ward and Brownlee are right, then this planet is not one ordinary rock among countless equals. It is closer to a miracle, a coincidence stacked upon coincidence until the odds against it become almost unspeakable. And a miracle is a lonely thing to be. To be rare is to be precious, and to be precious is to be fragile, and to be fragile is to understand, perhaps for the first time, exactly how much there is to lose. The comfort of company vanishes. In its place stands something heavier and quieter, the sense of a candle burning alone in an enormous unlit hall. Yet even this is not the end of the reading, because rarity is only one way to explain an empty sky, and it happens to be the gentlest. It asks us to believe that we are alone by accident, that the universe simply failed, again and again, to repeat the trick that made us. But there is another interpretation waiting just behind it, one that does not require the cosmos to be nearly empty at all, one that lets the galaxy teem with minds, and still leaves our own sky perfectly, deliberately silent. Consider what that interpretation would actually require. Not an empty galaxy, but a crowded one. Not a universe that failed to give us any company, but a universe brimming with it, aware of us, and choosing to say nothing at all. In the year 1973, a radio astronomer named John A. Ball, working at the Harvard-Smithsonian Center for Astrophysics, published a short paper in the journal Icarus that took this exact idea and gave it a name. He called it the zoo hypothesis. The proposal is simple, and once you have heard it, it becomes difficult to unhear. Perhaps the reason we detect no one is not that no one is out there. Perhaps it is that they have agreed, all of them, everywhere, to leave us undisturbed. Ball's suggestion was that intelligent life might be nearly ubiquitous across the galaxy. Not rare, not scattered like isolated candles in an unlit hall, but common, ancient, and patient. And these older minds, he reasoned, may long ago have set aside a small pocket of space and marked it the way we mark a wilderness. Not a cage, not a laboratory in any cruel sense, something closer to a nature preserve, a region left deliberately untouched so that whatever grows inside it grows entirely on its own terms. Earth, in this reading, is not overlooked. Earth is protected, and the silence is not an absence of neighbours. The silence is the sound of a rule being kept. There is something almost tender in this idea, and something deeply cold hidden just beneath the tenderness. It is a comfort to imagine that we are not alone, that the hall is not empty after all, that beyond the edge of our hearing there are others who know we are here and wish us no harm. But follow the logic one step further, and the comfort thins. For a zoo to stay silent, every keeper must agree. Not most of them, not the reasonable majority, all of them. Across thousands of light years and millions of years, not one civilization can break the pact. Not a single curious young species among the stars can wander over and tap on the glass. That kind of silence is not an accident, it is a discipline. And a discipline that complete implies an authority we cannot see and can barely imagine, a consensus enforced so perfectly that in 66 years of listening, we have not caught even one exception. This is the strange gift and the strange threat of the zoo hypothesis. It explains the great silence without asking us to believe that intelligence is rare. It lets the Drake equation keep its enormous numbers. It lets 300 million habitable worlds stay full of life. And it accomplishes all of this by moving the mystery from biology to sociology, from the question of whether they exist to the question of why they hide. The silence stops being evidence of an empty universe. It becomes evidence of a universe with rules. Rules we did not write. Rules we may not even be permitted to know. Ask most people what an empty sky means, and they will answer without hesitation. An empty sky means no one is home. That answer feels obvious, and it is wrong, or at least it is only one possibility among several. A sky can be empty because there is nothing in it. A sky can also be empty because everything in it has decided, for reasons of its own, to stay quiet. The observation is identical in both cases. A silent radio does not distinguish between an absence and a choice. And this is the trap the pivot closes around us. We have been reading the silence as a fact about the universe. It may instead be a fact about the observers hiding inside it. Here is the symmetry that should keep you awake, or perhaps, calmly, let you drift. Rare Earth and the zoo hypothesis point in exactly opposite directions, and yet they leave behind the identical sky. One says the universe is almost empty, the other says the universe is nearly full. One says we are a miracle that no one else managed to repeat. The other says we are a specimen that everyone else has quietly agreed to observe. And the maddening truth is that from where we stand, from inside a single solar system on one minor arm of one ordinary galaxy, the two explanations look precisely the same. An empty sky, a quiet radio, a question that returns no answer. We cannot tell the difference between being alone and being surrounded, because both produce a stillness that is total. Consider what this does to the search itself. For more than half a century we have pointed our instruments outward, assuming that if anyone were there, we would eventually hear them. But the zoo hypothesis suggests the search may be structurally incapable of succeeding. If the silence is a rule being enforced, then the enforcers will not answer no matter how long we listen, no matter how sensitive our antennas become. We would be like an animal in a preserve, pressing its ear to the fence, straining to catch a sound the keepers have taken great care never to make. The absence of a signal would not mean the absence of a signaler. It would mean the signaler is very, very good at staying hidden. And notice what we cannot do from inside. We cannot falsify it. Not easily. Not with any telescope we have built or plan to build. A rare universe and a watched universe both predict exactly what we see, which is nothing, and a hypothesis that predicts nothing is a hypothesis that resists every test. This is why the zoo hypothesis lives at the uncomfortable border between science and something older than science. It cannot be proven, it cannot be disproven, it can only be sat with, the way you sit with a thought late at night that you cannot argue away and cannot quite bring yourself to believe. And there is a reason to take the possibility seriously, beyond mere imagination. The galaxy is old. If minds arose elsewhere even a single billion years before us, they have had time we can barely conceive, time to spread, to mature, to outgrow whatever restless hungers drive a young species outward into the dark. A civilization that ancient would not be like us. It would not be like anything we can picture. Its patience would be geological. Its ethics, if it retained anything we would recognize as ethics, would have been refined across spans longer than the entire history of complex life on Earth. To such a mind, the choice to leave a fledgling world alone would not be a sacrifice. It would be trivial, a courtesy extended without effort, the way we might step around an anthill without breaking stride, and this reframes even our own attempts to be heard. We have not merely listened, we have shouted. We have sent our voice outward on purpose, encoded and deliberate, trusting that if anyone caught it they would answer in kind. The zoo hypothesis offers a colder reading of that trust. Perhaps our signals have already been received. Perhaps they were logged the moment they crossed the fence, filed away as the first faint noises of a species just beginning to find its voice. Not ignored out of indifference, but noted, and answered with the same disciplined quiet that greets us everywhere we turn. We assume silence means we have not yet been found. It may mean we were found long ago, and the finding changed nothing, because the rule was already in place. But there is a deeper unease still, and it is the reason the pivot does not end here. Both of these readings, the miracle and the menagerie, quietly assume a certain benevolence in the arrangement. The rare Earth universe is indifferent to us, but not hostile. The zoo universe is watchful, but protective. In both, the silence is either an accident or a kindness. Neither one asks the darkest question. Neither one considers the possibility that the silence is not empty, and not gentle, but strategic. That the reason no one is speaking is not that no one is there, and not that we are being carefully preserved, but that speaking, out loud into the dark, is the single most dangerous thing a living world can do. That every civilization capable of reaching the stars learnt the same lesson we have not yet learned, and fell silent on purpose, and is listening, right now, for anyone foolish enough to make a sound. This idea has a name, and it did not come from an observatory or a physics department. It came from a novel. In the year 2008, the Chinese writer Liu Cixin published a book called The Dark Forest, the second volume in a trilogy that had opened with a story about a dying alien world reaching across the void toward ours. The novel was fiction. The argument buried inside it was not. What Liu Cixin had done, almost in passing, was to take the plain logic of survival and apply it, without flinching, to the entire cosmos. He arrived at a conclusion so cold that once you have seen it, the night sky never looks the same again. The image at the center of it is simple. Picture the universe not as a cathedral and not as a laboratory, but as a vast forest after dark. In this forest, every civilization is a hunter, moving quietly between the trees, careful with every step. The hunter cannot see far. It cannot know what waits behind the next trunk, whether the shape in the shadows is weak or strong, gentle or starving, a fellow wanderer or a thing that eats wanderers. It knows only one fact with certainty. It knows that it is alive, and that it wishes to stay that way. And in a forest crowded with armed strangers who all share that single wish, there is exactly one behavior that keeps you breathing. You stay silent. You do not call out. You do not light a fire that anyone could see. This is the dark forest. And the reason it is so difficult to escape is that it is not built on malice. It is built on caution. Consider the logic step by step, because the horror of it lives in the details, not in the mood. The argument rests on a small handful of assumptions, and every one of them is something we already believe about ourselves. The first assumption is that survival is the primary imperative of any civilization. Not comfort, not curiosity, not kindness. Survival, first, before all other goals, because a civilization that does not prioritize its own continuation does not last long enough to have other goals. The second assumption is that resources are finite. The matter and energy of the universe, however staggering the numbers, are not infinite, and they do not replenish themselves. Two civilizations that both keep growing will eventually want the same stars. The third assumption is the one that turns caution into something lethal. Technological advancement happens at rates no outside observer can predict. Here is the problem. Imagine you detect another civilization somewhere in the dark. You learn its location. You even learn roughly where it stands on the long climb, from stone tools to starships. But your knowledge is already old. The light carrying that information may have crossed hundreds or thousands of years to reach you, and light is the fastest messenger there is. The civilization you are looking at is not the civilization that exists now. It is a photograph of a stranger, taken long ago, and you have no way to know what that stranger has become in the meantime. It might still be scratching in the dirt. Or it might, in the centuries your signal spent in transit, have undergone the same explosive leap our own species made, from horse-drawn carts to atomic weapons in the span of a single long human lifetime. You cannot afford to assume it stayed small. You cannot afford to wait and find out. And here is where the arithmetic becomes truly disturbing. Because you cannot know their intentions, and you cannot know their rate of growth, and you cannot risk being wrong, the safest thing you can do to any civilization you detect is not to greet it, not to study it, not to quietly withdraw and leave it alone. The safest thing you can do is to eliminate it, immediately, before it can grow into something that might one day eliminate you. This is not cruelty. This is not even hostility in any sense a human heart would recognize. It is the same reasoning a person uses when they lock a door they will probably never need locked. It is insurance. It is the coldest possible expression of the will to live. So every civilization in the forest faces the same terrible menu of choices and works through it in the same order and arrives at the same two conclusions. Stay hidden so that no one finds you, and if you ever do find someone else, strike before they can do the arithmetic you just did. Silence is not shyness in the dark forest. Silence is a survival strategy, refined across billions of years and countless dead worlds, until only the quiet ones remain. The loud civilizations are not out there broadcasting because the loud civilizations are not out there at all. They announced themselves once, long ago, and the forest answered, and now they are gone. Now extend that logic across deep time, and feel how it hardens from a possibility into something that behaves almost like a law. In a galaxy that has existed for billions of years, this game has not been played once. It has been played over and over, on world after world, for longer than our sun has burned. And a strategy that gets played that many times does not stay a matter of opinion. It becomes what game theorists call evolutionarily stable. Any civilization that chose to be trusting, to broadcast its position, to assume the best of its neighbours, was removed from the game. Its strategy died with it. What survives, generation after cosmic generation, is not the friendliest civilization, and not the wisest, and not even the strongest. What survives is the quietest. The universe is not silent because it is empty. The universe may be silent because silence is the only trait that lives long enough to be common. That is the piece that makes the dark forest so much heavier than the answers that came before it. The rare Earth universe was indifferent, but it left room for hope. The zoo universe was watchful, but it was, in its way, tender. The dark forest offers neither indifference nor tenderness. It offers a full and crowded cosmos, teeming with intelligence, in which every single participant has independently concluded that the correct response to a stranger is to say nothing and prepare for the worst. It is the most populated version of the silence, and the most frightening, because in this reading, the great emptiness we hear when we point our antennas at the sky is not the absence of neighbours. It is the sound of a great many neighbours, all holding their breath at once. And now consider what this means for us, because we have not been holding our breath, we have been shouting. On November 16th, 1974, at the Arecibo Observatory in Puerto Rico, human beings did the one thing the dark forest says a young civilization must never do. We announced ourselves on purpose. To mark the upgrade of that enormous dish, scientists composed a message and beamed it into space, deliberately, as a demonstration of what our young technology could reach. The message was small by the standards of a modern data file, just 1,679 binary digits, roughly 210 bytes of information, a string of nothing but ones and zeros. But those ones and zeros were chosen with enormous care. Arranged correctly, they drew a picture. They spelled out the numbers we count with. They sketched the chemistry of the molecule that carries our heredity, the double helix of our DNA. They drew the shape of a human being, and our average height, and how many of us were alive. They mapped the planets of our solar system, and marked, with a small rise in the pattern, the third rock out from the sun. The world we live on, our home address, written in mathematics, so that any mind capable of arithmetic could read it. The broadcast went out at a frequency of 2,380 MHz, driven by 450,000 watts of power, a concentrated burst brighter for a moment than the sun itself at that wavelength. And it was aimed at a specific target, not a random patch of sky, but a dense knot of stars called Messier 13, the Great Hercules Cluster, a glittering swarm of roughly 300,000 suns bound together by their own gravity. It was a magnificent, hopeful, almost innocent gesture. Here we are, the message said. This is what we look like. This is where to find us. And here is the detail that turns the gesture from hopeful to almost unbearable, if the dark forest is real. Messier 13 sits 25,000 light years away. 25,000 years for the message to arrive, travelling at the absolute speed limit of the universe, which means that even in the best imaginable case, Even if someone in that cluster is listening and kindly disposed and eager to reply, the answer could not reach us for at least 50,000 years. We will never hear back. Everyone alive when that signal was sent will be 50,000 years in the grave before any response could return. The message was not a conversation. It was a flare, fired into the forest, by a species that had not yet stopped to ask whether the forest was empty, or whether something in it might be watching for exactly that kind of light. And the Arecibo message was only the loudest of our shouts, not the only one. For decades before it, and every decade since, our television broadcasts, our radar, our ordinary radio chatter have been leaking outward from Earth in an ever-widening bubble, an unintended announcement expanding at the speed of light in all directions at once. We did not decide to be visible. We became visible simply by becoming modern. For a full century now, that bubble has been widening, silent and unstoppable, carrying the faint fingerprint of our civilization outward at the only speed the universe allows. The nearest few hundred stars have already been touched by it. Any receiver pointed at our small yellow sun from those distances would find, buried in the noise, the unmistakable signature of a world that had learned to speak in radio, not a natural signal, not the hiss of hot gas or the slow pulse of a spinning star, the ordered artificial chatter of a species announcing itself without ever intending to. We have been broadcasting our address for longer than anyone now living has been alive. In 2008, the Chinese writer Liu Cixin gave this quiet dread a name and a shape. In a novel titled The Dark Forest, he proposed a way of seeing the cosmos that once seen is very difficult to unsee. Imagine the universe not as an empty cathedral waiting to be filled, but as a vast forest at night. In that forest walks every civilization that has ever arisen, each one an armed hunter, moving carefully between the trees. The hunter cannot see far. The hunter can only catch the occasional snap of a branch, the rustle of something else moving in the dark. The hunter has learned, through a logic we will now follow step by patient step, that the only safe response to any sign of life is to raise the rifle and fire. The logic begins with a premise almost no one would dispute. Survival is the first imperative of any civilization. Not comfort, not curiosity, not kindness, but survival. Because a civilization that does not place its own continued existence above all else does not remain a civilization for very long. The second premise is nearly as simple. The resources of the universe are finite. There is only so much matter, only so much energy, only so much room, and every civilization that grows must eventually compete for the same shrinking supply. These two ideas alone are gentle enough. It is what happens when you combine them across the distances of space that turns gentle into lethal. This is the mathematics that everyday experience hides from us. On Earth, when we are unsure of a stranger, we can watch them, speak with them, take their measure over the course of an afternoon, and slowly decide whether to trust them. Distance here is a thing we cross in hours. Space converts distance into time, and it does so without mercy. The nearest stars lie years away at the speed of light. The far side of the galaxy lies 100,000 years away. At those scales, there is no afternoon in which to take anyone's measure. There is only the message you sent, drifting outward, and the unknowable thing that might receive it long after you are dust. The instinct that keeps us safe among strangers, the slow building of trust, is a tool that simply does not function across the gulf between the stars. So the reasoning tightens toward its blade. You cannot know their intentions. You cannot know their rate of growth. A civilization that seems harmless and primitive today might, in the centuries it takes your warning to arrive, leap so far ahead in technology that it could extinguish you before you understood the threat. And so every hunter in the forest arrives at the same terrible conclusion. You cannot communicate safely. You cannot wait to find out. The only move that guarantees your survival is to reveal nothing, and upon detecting anyone else, to eliminate them before they can eliminate you. Not out of hatred, not out of malice or conquest or greed, simply out of the cold arithmetic of a game in which the first to be seen is the first to die. This is what a game theorist would call an evolutionarily stable strategy, a behavior so successful at ensuring survival that any civilization which fails to adopt it is eventually removed from the forest, leaving only the silent hunters behind. Consider what this means across deep time. The universe is 13.8 billion years old. In all those billions of years, in a galaxy of 200 to 400 billion stars, the civilizations that survived would not be the loudest, not the friendliest, not the most curious or the most eager to reach out. The survivors would be the quiet ones, the ones that learned early to make no sound, to send no message, to hide their small worlds behind a wall of deliberate silence. Every civilization that chose to broadcast, that chose to announce itself in hope of an answer, would have been a candle lit in a dark room full of predators. Candles, in such a room, do not burn for very long. Imagine a young civilization somewhere in that galaxy, no wiser than we are, discovering radio for the first time and doing exactly what we did. Imagine it sending out its own bright and hopeful signal, its own map, its own proud announcement that it exists. Imagine that somewhere in the darkness, something older and colder receives it, notes the coordinates, and acts. That civilization would never know what happened. There would be no warning, no negotiation, no reply. There would only be a silence that fell and stayed and told the rest of the forest one more time that speaking is a fatal mistake. Perhaps that has already happened 1,000 times. Perhaps the silence we hear is not the absence of voices, but the echo of every voice that was foolish enough to speak. Now turn that logic back toward Earth and feel it settle. For 66 years we have been doing precisely the thing the dark forest says no surviving civilization ever does. We have been listening, yes, but we have also been shouting. The Arecibo message we sent in 1974 was not a whisper. It was fired at 300,000 stars at once with almost 500,000 watts of power, a deliberate declaration encoded with our mathematics, the structure of our DNA, the shape of the human body, and a map showing exactly which star we orbit. If the dark forest is real, we did not send a greeting. We sent a set of coordinates. We handed a hunter our address and drew a small arrow pointing at the door. It was not only Arecibo. Every radar sweep meant to track aircraft, every television signal carrying entertainment into homes. Every burst of ordinary communication has been climbing away from this planet for a century, an accidental beacon we never chose to light. We did not weigh the risk. We did not gather as a species and decide that visibility was worth the danger. We simply grew up, the way a child grows up, loud and unafraid, assuming without ever asking that the dark around us was empty and friendly. The dark forest hypothesis suggests it may be neither. It suggests that our silence would have been the wiser choice, and that we abandoned it before we even knew there was a choice to make. This is the most unsettling possibility in the entire question of the silence. Not that the universe is empty, not that life is rare, but that the universe is full and quiet on purpose, and that the quiet is a kind of wisdom every survivor learned long ago. If that is true, then the decades in which humanity has been calling into the dark were not a noble search for companionship. They were decades of lighting a signal fire in the middle of a minefield, waving toward the trees, waiting for a friend, unaware that the safest thing anyone in that forest can do is never answer, and that the second safest thing is to make certain the fire goes out. Whether that terror is the truth, or merely one story among several, depends on something we have barely begun to examine: how little of the forest we have actually looked at, and what, on one August night, we may have briefly heard looking back. Start with the smaller of those two ideas, the one that asks not for courage, but for humility. Before the silence is allowed to frighten us, before we hand ourselves over to any of the stories that try to explain it, there is a question so plain it feels almost unworthy of the subject. Have we actually listened? Not listened the way a person listens for footsteps on a path. Listened the way a science listens, patiently, deliberately, across the staggering range of directions and frequencies and moments in which a message from another world might happen to arrive. The honest answer is that we have barely begun. To understand why, you have to understand what searching the sky for a signal truly requires. It is not a matter of pointing an antenna upward and waiting. A civilization hoping to hear another civilization must guess correctly along 4 separate dimensions at once. And a wrong guess on any single one of them means hearing nothing at all. You must guess the direction. The sky holds hundreds of billions of stars in our galaxy alone, and a radio telescope hears only a tiny patch of it in any instant. A keyhole aimed at one distant point, while the rest of the heavens go unheard. You must guess the frequency. The span of the radio spectrum a message might ride across is enormous. Millions upon millions of possible channels, and a receiver tuned to one narrow band is deaf to all the others. You must guess the bandwidth of the signal itself, and you must guess the moment, because a transmission that sweeps past the Earth for an hour, or a minute, or a single second, is gone the instant the beam moves on, and it may not return for 1,000 years. This is why the first serious proposal for the search was, above all else, a proposal about where to point. In 1959, 2 physicists named Giuseppe Cocconi and Philip Morrison published a short paper in the journal Nature titled Searching for Interstellar Communications. Their insight was not about building a more sensitive instrument. It was about the mind of a stranger, about what any thinking spaces would choose. They reasoned that a technological civilization, anywhere in the cosmos, would know one particular frequency, because it is written into the physics of the most common substance in existence. Hydrogen, drifting through cold space, gives off a faint radio note at 1420 MHz. Every astronomer in the universe would eventually find that note. It would be, the 2 men argued, a natural meeting place, a frequency everyone knows, where everyone might think to gather. Later searchers gave it a gentler name. They called it the watering hole. And so, for 66 years, that is roughly where humanity has aimed its ears. Project Ozma listened there. The searchers that came after listened there. Yet even now, after decades of great dishes turning slowly across the sky, the total volume of what we have examined remains almost nothing. Picture the full space of every possible signal, every direction, every frequency, every bandwidth, every passing moment, as an ocean. Everything the entire search has covered, in all its history, amounts to a single glass of water dipped from that ocean and held up to the light. One glass, against a sea whose far shore we cannot even see. This is the tiny hope buried inside the terror. The silence we have been fearing is not the silence of an empty universe. It is the silence of a room we have only just stepped into, in which we have cupped one hand to an ear for the briefest of moments and heard, so far, nothing come back. The argument from silence, the reasoning that insists they are not out there because we do not hear them, is not yet an argument at all. It is a sample far too small to carry the enormous weight we keep placing upon it. Absence of evidence, on a search this shallow, is not evidence of absence. It is barely evidence of anything. And yet, in that single glass of water, dipped just once from an unimaginable ocean, there was one drop that did not behave like all the others. It arrived on a warm night near the close of the summer of 1977, and almost half a century later, no one has been able to fully explain it, and no one has ever heard it again. The telescope that caught it was called Big Ear, a vast stationary instrument at Ohio State University. It was far too large to move, so it did not track the stars at all. It simply stared straight up and let the turning of the Earth carry the heavens slowly through its gaze, so that each point in the sky drifted across its view and out again over the span of a few minutes. On the night of the 15th of August, 1977, at 16 minutes past 10 in the evening, Eastern Standard Time, the instrument was aimed toward the constellation Sagittarius, toward the crowded heart of our own galaxy, listening close to that watering hole frequency Cockney and Morrison had marked out 18 years before. The astronomer who reviewed the data was a man named Jerry Amon. He was not watching in real time. He was doing what most of the search has always quietly been, the unglamorous part. Reading a printout of numbers days after the fact, columns of characters describing how loud each patch of sky had been at each moment. Nearly all of them the low, flat mumble of ordinary background noise. Then, running his eye down one column, he found something that stopped him. A sequence of 6 characters, rising and then falling away, tracing a signal that climbed high above the noise, held and faded. The reading was set down as a 6, then the letters E, Q, U, J, and then a 5. In that shorthand, each character stood for an intensity, and the letter U was extraordinary. It marked a signal that rose 30 to 31 standard deviations above the ordinary hiss of the sky, which in plain terms means something cleaner and louder than anything the telescope had ever caught from beyond the Earth. Eamon looked at it for a long moment. He took up a red pen, and he circled the 6 characters on the page, and in the margin beside them he wrote a single word. Wow. That word became the signal's name, and the name has outlived the telescope that earned it. Consider what the signal actually did, and why it has haunted the search ever since. It lasted 72 seconds, which is exactly how long any fixed point in the sky needed to drift through Big Ear's field of view. This detail matters more than it first appears. The signal did not switch on and then switch off. It rose and fell in precisely the shape a steady source far out in space would trace, brightening as the Earth's rotation swept the telescope onto it, dimming smoothly as it swept away. It behaved, in every measurable respect, like something genuinely out there among the stars, not like a burst of interference leaking up from the ground below, and it sat almost exactly where a message was meant to sit. Cockney and Morrison had predicted the watering hole. The WOW signal arrived at 1420.4556 MHz, a razor's breadth from the pure hydrogen note itself at 1420.4058. Not adrift somewhere in the vast, arbitrary middle of the radio spectrum, but resting on the one frequency 2 physicists had guessed, decades earlier, that a stranger would choose to speak on. Then it was gone. Big Ear had no way to chase it, no ability to swing back and hold on. And in the years that followed, again and again, people returned to that patch of Sagittarius and waited for it to speak a second time. The astronomer Robert Gray gave years of his life to it, coming back in 1987, in 1989, and once more across 1995 and 1996. He borrowed the Very Large Array in New Mexico, a formation of enormous dishes far more sensitive than Big Ear had ever been. Others took up the watch as well. The University of Tasmania looked in 1999. Decades later, in May of 2022, Breakthrough Listen, the most powerful search ever assembled, turned its full attention to the same stretch of sky. Every one of them found the same thing waiting in that spot. Nothing. The most sensitive ears humanity has ever built pointed for years at the one place the universe appeared to have spoken, heard only the flat, indifferent hiss of the background, over and over, decade after decade after decade. So there it stays. One knock at the door, on one summer night, loud and clean and landing on the precise frequency we had been told to expect. And then a silence that has now held for very nearly 50 years. What that single knock truly was, whether it was a voice, or an accident, or something stranger sitting between the two, is a question worth holding gently for a while, because it is the closest the search has ever come, and because the ways we have tried to explain it away turn out to be almost as revealing as the signal itself. The ways we have tried to explain it away all carry a heavy load. To wave the signal off as an accident of nature, you must first explain its shape. It was narrow, it was focused. It sat on a single frequency, the way a held note sits at the center of a song, and it climbed to somewhere between 30 and 31 times the strength of the background hiss around it. Natural static rarely arrives so clean, so sharp, so precisely tuned to the one frequency that Giuseppe Coccini and Philip Morrison had named in a paper in 1959, 18 full years before anyone actually heard it. That is a remarkable amount to ask of a coincidence. And to call it a message instead, you must explain the silence that swallowed it. Not a brief silence, a silence now measured in decades. So the honest answer, the one the scientists themselves keep returning to, is the least satisfying answer imaginable. Nobody knows. It is not that we have proven the signal was a voice. It is not that we have proven it was nothing. It is that the single most promising thing the search has ever heard remains suspended between those two verdicts, impossible to confirm and impossible to kill. Every instrument that has since turned toward that patch of the constellation Sagittarius has come back with empty hands, and every empty hand deepens the mystery rather than closing it. A confirmed source would repeat. A simple mistake would usually leave a fingerprint. This did neither. Consider what happened to the ear that heard it. The telescope did not survive to defend its own discovery. In 1997, the enormous horn-shaped dish at Ohio State University, the instrument affectionately called the Big Ear, was pulled down and cleared away. Not for a grander machine, not for a more sensitive successor built to chase the very thing it had found. It was demolished to make room for a golf course, part of the expansion of a real estate development on the land beside it. The one structure that had ever caught a clean knock at humanity's door was flattened into fairways and turf. The signal outlived the antenna that recorded it, which is a strange and quietly devastating thing to sit with. It would be comforting to imagine the search as a steady, unbroken vigil, humanity leaning toward the sky with patient and continuous attention. The reality is far more fragile than that. In 1981, Senator William Proxmire slipped an amendment into a budget and terminated the entire program in a single stroke. It was reinstated in 1992 and then cancelled again by Congress in 1993, barely 1 year into a $100 million, 10-year high-resolution microwave survey, forcing the search for other minds in the universe to survive on private money ever after. The listening did not stop because we heard something that frightened us. It stopped because a line in a budget was easier to cut than to defend. The listening that remains has been rescued, again and again, by individuals rather than governments. In January of 2016, the internet entrepreneur Yuri Milner committed $100 million of his own fortune to a project called Breakthrough Listen, the largest and most ambitious search ever assembled. Its stated goal is almost dizzying in scope: to survey 1 million nearby stars, to sweep the entire plane of our galaxy, to stare into the crowded galactic center, and to examine 123 neighboring galaxies, all across a span of 10 years. It is the closest thing we have ever built to a genuine effort to answer Fermi's question, and in all its listening so far, across all that sky, it has recorded not one confirmed technosignature, nothing that survives a second look. Here is the part that should give you pause, and perhaps also give you comfort. 1 million stars sounds like an unimaginable number, and it is. Yet the Milky Way holds somewhere between 200 billion and 400 billion stars, and 1 million of them is a rounding error against that total, a single grain lifted from a vast beach. To search 1 million stars out of hundreds of billions is to dip a single glass of water from an entire ocean, examine it under the light, find no fish, and announce that the ocean is empty. The silence we have gathered is real, but it is not yet a silence that means anything. The sample is simply far too small to carry the weight we keep trying to hang on it. This is where the hope lives, thin and cold and genuine. We have not searched the galaxy and found it barren. We have searched a sliver of it, along a narrow band of frequencies, for a fleeting handful of decades, using instruments that keep getting demolished or defunded. The great silence may not be the universe telling us we are alone. It may only be the sound of a species that has barely learnt to listen, cupping one ear toward an ocean of stars and mistaking its own inattention for an answer. The argument from silence, pressed too hard, collapses under its own thinness. We have not proven absence. We have proven only that we have hardly begun. And yet the dread returns through the same door the hope walked in. Because the one time we did dip the glass, on one summer night in 1977, something may have been there, something clean, something loud, something sitting on exactly the frequency we had been told to expect. And we caught it for 72 seconds, and then let it slip back into the dark before we could be sure of what we held. If the ocean is truly empty, that single knock is a torment, an accident dressed up as meaning. If the ocean is full, that single knock is worse, because it suggests the voices are out there, and we are simply too small, too slow, and too easily distracted to hold on to them when they come. Either way, the water ran through our fingers. So this is the ledger as it actually stands. 300 million potentially habitable worlds in our galaxy alone, and at least 4 of them within 30 light years of where you are lying right now. A search that has been switched off, switched on, defunded, and privately resurrected more than once across 66 years. A single anomaly, unrepeated, matching the predicted profile of an alien transmission almost perfectly, recorded by a telescope that no longer exists. And beneath all of it, an ocean we have sampled by the glassful. The numbers on one side of the ledger scream that we should not be alone. The numbers on the other side, the ones describing how little we have truly looked, whisper that we would not yet know it even if we were surrounded. Neither column balances the other. Both are honest. Both are incomplete. To understand what that unbalanced ledger is really telling us, we have to do something the instruments cannot do for us. We have to set down the frequency charts and the funding histories and the single circled anomaly, and step back far enough to see the whole thing at once. Not one telescope, not one signal, not one night in Sagittarius. The entire arrangement of it, a universe of unthinkable size, a species young enough to still be surprised by its own reflection, and a question first asked at a lunch table that no answer has yet dared to close. There is a temptation, at the end of a long inquiry like this one, to reach for a verdict, to weigh the 2 columns of the ledger one final time and declare which of them wins. That temptation should be resisted. The honest answer is that nobody knows, and the pretense of knowing would betray everything the search has actually taught us. So in place of a verdict, hold instead a small set of possibilities, all of them side by side, none of them yet ruled out. Each one casts a different light across the same silence. And the strange thing, the thing worth sitting with as the mind begins to slow, is that the light changes the meaning of the dark completely. Perhaps the silence means exactly what it appears to mean. Perhaps we are, in the way that matters most, alone. Perhaps the chain of accidents that produced a thinking animal on this particular world, the stable star and the steadying moon, the gas giant standing guard against bombardment, the slow patient cycling of carbon through moving plates, is so improbable that it has happened only rarely across 2 trillion galaxies. Not because the universe is hostile to life. Microbes may be scattered everywhere, in the dark oceans beneath icy moons and the damp rock of 100 million worlds, but because the road from a single living cell to a creature that can ask where everybody is, may be a road almost nothing ever finishes. If that is true, then the silence is not an absence. It is a mirror. It is the universe showing us how rare the act of looking really is. Or perhaps the silence means something gentler and stranger. Perhaps we are not alone at all, but watched. In 1973, a radio astronomer named John Ball, working at the Harvard-Smithsonian Center for Astrophysics, proposed that intelligent life might be nearly everywhere, and that its very abundance is the reason we hear nothing. He called it the zoo hypothesis. The idea is simple and difficult to shake. A civilization far older than ours, or many of them acting together, might hold to an ethic of non-intervention, setting aside young worlds like this one as a kind of wilderness area, a preserve left deliberately untouched so that whatever grows here grows on its own terms. If that is the case, then the quiet is not neglect, it is care, and from inside the enclosure there is no experiment we can run that would tell us the fence is there. Or perhaps the silence is neither accident nor kindness, but strategy. In 2008, the science fiction writer Lou Cixin gave the darkest of these possibilities its most memorable form. He imagined the universe as a dark forest, and every civilization within it as a hunter moving quietly among the trees. Survival comes first. Resources are finite, and no hunter can ever know whether the stranger across the clearing is harmless or lethal, or how fast that stranger might grow. Under those conditions, the rational move is not to call out. The rational move is to stay silent, and to eliminate anything that reveals itself before it can become a threat. If that logic holds, then the silence is not empty and it is not safe. It is the held breath of everyone who learnt the rules before we did. It is the sound of a forest in which the wise have already decided that the only safe voice is no voice at all. Here is what makes this moment so difficult and so quietly overwhelming. All three of these explanations account for the silence equally well. The empty universe and the watched universe and the hunted universe produce, from where we sit tonight, precisely the same experience, a sky full of stars and a receiver full of static. We cannot tell them apart, not because we are not clever enough, but because we do not yet have the one thing that would separate them, which is more than a single glass of water drawn from an ocean we have barely begun to sound. Every framework we built to tame this problem, the equation written on a blackboard in West Virginia, the ladder of hard steps sketched by an economist in 1998, was in the end a way of turning dread into arithmetic. And arithmetic only comforts you when you can trust the numbers going in. These numbers we do not yet have. We have one confirmed example of life becoming aware of itself, and it is the one doing the counting. So the question that Enrico Fermi asked over lunch on a summer day in 1950, the question that landed like a joke and outlived the man who spoke it, turns out to have no answer that does not first ask something of us. This is the part the instruments cannot reach. A telescope can measure a frequency. It can log the 30 standard deviations of a signal that never returns. It cannot tell you what to do with the fact that the sky, so far, has answered only once, and then fallen quiet. That is not a measurement. That is a choice. And the choice does not belong to the equation, or the observatory, or the funding committee that shut the search down and reopened it, and shut it down again. It belongs to whoever is listening. Because notice what Fermi's question quietly does. On its surface, it is a question about them, about the missing others, about the empty chairs at a table that should by every reasonable estimate be crowded. But turn it over, and it becomes a question about us. Do we broadcast, announcing ourselves across 25,000 light years the way a message once left the great dish at Arecibo? Or do we listen and say nothing, as the darkest of the forests would counsel? Do we keep pointing our antennas at the constellation Sagittarius, hoping the one knock comes again? Or do we accept that the ocean is too vast and the glassful too small to conclude anything at all? Do we treat the silence as a verdict already delivered, or as a question still genuinely open? None of these has a universal answer. Different people, across different centuries, will weigh the same silence and hear entirely different things inside it. Some will hear loneliness. They will look at 300 million potentially habitable worlds in this galaxy alone, and at the emptiness pouring back from everyone we can examine, and they will feel the full cold weight of being the only voice in an unimaginably large room. Some will hear safety instead, and be grateful for the quiet sensing in it a fence built for our protection by hands we will never see. And some will hear a warning, and understand the silence as the accumulated wisdom of everyone who came before, every civilization that faced the same lunch table question, and answered it by going dark. The remarkable thing is that none of these listeners is being foolish. The silence is genuinely large enough to hold all of their answers at once, and honest enough to confirm none of them. And this is where the whole enormous inquiry finally circles back and settles, not on a distant star, but on the one who has been listening all along. You are, at this moment, a member of a species young enough to still be startled by its own reflection. We built the receivers only 66 years ago. We have listened, in total, for a span that would not register against the age of a single hillside, let alone the 13.8 billion years the universe has been unfolding. We are not the tired old civilization at the end of its story, weary of the search. We are the one that has only just learnt the sky can be listened to at all, standing at the very beginning of the looking, with almost the entire ocean still ahead of us, and only the first glassful drawn. That youth is not a weakness. It is the most hopeful fact in the entire account. It means the argument from silence is not yet an argument about the universe. It is still for now an argument about the shortness of our attention and the smallness of our reach. A single word, written once in red ink beside a strip of numbers, is not proof that the cosmos is empty. It is proof of how recently, and how briefly, we began to pay attention. And when you set that youth against the sheer scale of what surrounds it, the loneliness starts, very slowly, to change its shape into something else. It changes into something closer to privilege. To be early is not to be abandoned. It is to be present at the opening of the longest story there is, before the ending has been written, before the outcome is known. We do not yet know whether the great silence is the silence of an empty house, or the silence of a room full of people holding their breath. And that not knowing, which feels at first like a wound, is in truth the rarest and most precious position a thinking creature can occupy. So consider the possibilities without choosing between them, because the honest answer is that nobody knows. Perhaps the silence means we are genuinely alone, the first to open our eyes in this corner of the cosmos, and the universe is not ignoring us but waiting for us, holding a door that no one else has yet walked through. Perhaps the silence means we are watched, and quietly protected, kept in a kind of wilderness the way John Ball imagined in 1973, allowed to grow undisturbed until we are ready to be spoken to. Or perhaps the silence is the sound of every civilization that came before us, arriving at the same fork in the same dark forest, and making a choice we have not yet been forced to make. These questions have no universal answers. They never will. Different people, standing under the same stars, will read the same silence and hear entirely different things inside it. One will hear proof that we are precious beyond measure. Another will hear a warning to stay quiet. Another will hear an invitation to call out louder. The paradox that Enrico Fermi tossed across a lunch table in 1950 was never really a question about aliens. It was a question about us. It asks what kind of civilization we intend to become, whether the loud kind or the quiet kind, the reckless kind or the patient kind, and it hands that decision, still unanswered, to you. Consider what you are actually a part of. You exist inside a cosmos that holds roughly 2 trillion galaxies. Within those galaxies burn something close to 200 billion trillion stars, a number with more than 20 digits, a quantity you cannot truly picture no matter how long you try. This has all been unfolding for 13.8 billion years, an expanse of time in which entire generations of stars have lived and died before our own sun was born. And in all of that, across every galaxy and every star and every silent age, there is exactly one place we know of where matter woke up and looked back at the sky. One planet. One species. One radio telescope, on one warm night, catching one 72-second whisper it could never find again. And one astronomer reaching for a red pen to write a single startled word in the margin. That is not a small thing. That is very nearly the whole miracle. The silence, then, is not the proof of absence it first appears to be. We have not searched the ocean. We have drawn a single glass of water and found it clear, and mistaken that for knowing the sea. 66 years of listening is not a verdict. It is a first sentence. The emptiness we think we hear is not the universe telling us we are alone. It is the universe telling us the question is still open. And an open question is not a tragedy. An open question is an invitation. It means the story is not finished, that the most important thing we could ever learn has not yet been ruled out, that somewhere among the 2 trillion galaxies the answer may already exist and has simply not reached us, or may not exist at all and is ours alone to become. Either way, the looking is not over. The sky is still there, still turning, still full of light that left its source long before there were eyes on Earth to receive it. We are young enough that everything remains possible, and old enough, at last, to have learned how to listen. So let the silence settle over you the way it settles over a radio dish at the end of a long night, vast and cold and strangely gentle. Let it be the last thought before sleep, that we are here, awake, in a universe that has given us exactly one word and an endless amount of sky. The sky has not answered. But we have only begun to listen, and an open question is not an empty one. Not yet.